Have you ever heard a story and you're just like, wait a minute, what now? And then it just keeps getting more and more wild?
Yeah.
Well, that's kind of how I've been feeling about this whole Proxima B situation,
Oh, yeah.
our nearest potentially habitable exoplanet.
Right.
And there's been this like huge breakthrough
Big time.
in how we understand it.
Yeah.
It's really like revealing all these secrets that we didn't even know were there.
Totally hidden in plain sight.
Yeah.
It's incredible. Proxima b has been this puzzle that we've been trying to put together ever since we first discovered it.
Right.
Orbiting, Proxima Centauri, the closest star to our own solar system.
Right.
And the big question, of course, has always been, is there any chance that it could support life?
Right.
And we've been gathering so much data for years.
Yeah.
But it's just been so incredibly difficult to actually, understand everything.
Yeah, just the sheer volume of information from the James Webb Space Telescope.
Oh, it's immense.
It's wild. And it's funny because I was thinking about it the other day, and it's kind of like if you're at a rock concert
Yep.
and you're trying to hear like a pin drop,
Right.
that pin drop is Proxima B's secrets.
Right.
And that roaring music is like all the noise and interference in the data.
Wow. Yeah, that's a great analogy.
But scientists at NASA just did something incredible.
Yeah.
They figured out how to use this advanced quantum AI processing to like cut through that noise.
Really isolate that pin drop.
Yeah, and it's not just a small improvement.
No.
This is like a total game changer.
Oh, absolutely.
It's like they unlocked patterns that regular computers couldn't even see.
Couldn't detect. No.
Yeah, so I think what we should try to do today is unpack exactly what this new analysis has revealed about Proxima B.
On game.
For all of you listening out there, we want to give you the good stuff.
The key insights.
Yeah, without getting too bogged down in the, super technical.
Right. Right.
So we'll be looking at everything from the James Webb data, which has been analyzed by this quantum AI,
Yes.
to what all the brilliant astrophysicists and planetary scientists are saying about it.
The people on the front lines.
Yeah, so let's start with the first big reveal. What exactly did this quantum AI find in Proxima B's atmosphere?
Well, the very first thing, and it is quite intriguing, is
Yeah.
it detected these unusual spectroscopic signatures,
Okay.
which are essentially these unique fingerprints of light that tell us what gases are present in the atmosphere.
Gotcha.
And what they found was an unexpected concentration of methane.
Methane.
Yes, and here's the thing. It doesn't just stay at a constant level.
Right.
It fluctuates
It fluctuates.
in a very regular pattern.
Regular fluctuations of methane. Now that sounds familiar.
It does indeed on Earth.
Yeah.
Methane, with that kind of predictable variation, is often linked to biological processes.
Right, like wetlands releasing methane or even just, living organisms.
Think about how wetlands release more methane in warmer seasons,
Right.
or even the digestive systems of living organisms.
Yeah.
Now, we need to be very clear here. This doesn't automatically mean there's life on Proxima b.
Of course, of course.
But the fact that traditional computer analysis completely missed these subtle ups and downs, while the quantum AI could pull that signal out of all the noise by recognizing these complex correlations
Yeah.
across a huge amount of data that's incredibly significant.
So it was basically just hidden in plain sight.
It was. It really was.
Wow.
The previous analysis just couldn't see the forest for the trees.
Yeah, that's wild.
And now we have this potential link to biological processes.
Right.
It's a possibility that was entirely missed before.
That's so cool. So you're saying that before the AI, it just looked like random atmospheric noise?
Precisely what seemed like just jumbled data suddenly resolved into these clear cyclical patterns after the quantum AI went to work.
Wow.
So this immediately suggests two main possibilities. Either we're seeing true seasonal changes on Proxima b driven by its orbit,
Oh.
or there could be something much more fundamental and potentially biological happening with the planet's chemistry.
Right.
It raises a lot of exciting questions.
It really does. And speaking of seasons, that was the second big wow moment from this analysis, wasn't it?
Oh, yeah.
So tell us a little more about these potential seasonal shifts on a planet with such a short year.
Yeah, so the quantum AI dug deeper into the atmospheric data and identified clear seasonal variations in Proxima b's composition.
Oh.
And these aren't just vague suggestions. They follow a predictable 11.2 Earth day cycle,
Wow.
which Remarkably is Proxima B's year as it rapidly orbits its star.
A year and 11 days? That's insane.
It is fast.
But still having distinct seasons. I mean, I would have thought a tidally locked planet would have, like, incredibly extreme temperature differences,
Right.
Like one side super hot, the other side freezing.
Yeah, the initial assumption was a scorching day side and a freezing night side for sure.
But you're saying that there's this global circulation that's mitigating this.
It seems so.
That's wild. What specifically did the AI find that points to global circulation rather than just localized, weather effects?
Well, it's the patterns revealed by the AI by correlating subtle changes across multiple wavelengths that strongly suggest a global atmospheric circulation system.
Gotcha.
Think of it like weather patterns on Earth,
Okay.
distributing heat and chemicals around the planet.
Right.
This efficient heat transfer would lead to much more moderate temperatures across the globe
Wow.
and potentially a wider habitable zone than our earlier models predicted.
So from a potentially frozen wasteland on one side and a baked desert on the other, we're potentially looking at a more nuanced picture with at least pockets where liquid water could exist.
Yeah, it really opens up the possibilities.
That's incredible, and perhaps even more exciting is the potential for liquid water to
Right.
exist, at least in some regions,
Right.
through evaporation and precipitation,
Exactly, key components of a water cycle.
which would dramatically boost the prospects for habitability.
It would indeed. It takes Proxima B from a potentially barren world to one with genuine niches for life.
That is huge. So we've got methane fluctuations, we've got these crazy short seasons, but the discoveries didn't stop there, did they?
I did not.
We also heard about some rather unexpected heat signatures.
Yes, the third major revelation came from the Webb Telescope's HEAT camera, its mid-infrared instrument, or MII.
MARI.
Yes, capable of detecting incredibly tiny temperature differences on the planet's surface from vast distances.
Really?
The quantum AI processing of this thermal imaging data revealed distinct thermal hotspots on Proxima B's surface.
Thermal hotspots.
And what's so surprising is that these aren't just gradual temperature shifts.
Right.
They are localized areas primarily along the terminator line, that twilight zone between the day and night sides,
Right.
that are significantly warmer,
Okay, warmer by how much?
up to 15 degrees Celsius warmer than their surroundings.
15 degrees, that's like finding little warm patches in an otherwise uniformly cold or hot area.
Those are what we're calling thermal oases?
I love that thermal oases.
Yeah,
But why are they our current models didn't predict anything like this?
that's the key puzzle. Traditional analysis only showed those expected gradient temperature changes.
Right.
The quantum AI, with its ability to process multi-wavelength infrared data while filtering out the intense glare from Proxima Centauri, was crucial in pinpointing these anomalies.
So what are the leading hypotheses?
Well, Dr. Jim and Glades Goudet, who were instrumental in the planet's discovery, suggest these could be areas of geological activity,
Okay.
perhaps volcanic regions releasing heat from the planet's interior.
Little planetary geysers.
Yeah, like little planetary geysers.
What are some of the other ideas about these thermal oases?
Well, Dr. Victoria Meadows proposes the idea of thermal inertia.
Okay.
Certain surface materials might retain heat from the day side and release it more slowly into the twilight zone, creating these warmer patches.
Interesting. And for someone trying to picture this, are we talking about areas the size of lakes, continents, something else entirely?
While the exact size isn't known yet, the data suggests distinct, localized regions rather than planet-wide phenomena.
Gotcha. So maybe not a whole continent of volcanoes,
Yeah.
but okay, so we've got volcanoes, we've got weird rocks. What else?
And then there's Dr. Abel Mendez's intriguing hypothesis.
Okay.
These hotspots could indicate large bodies of liquid water acting as thermal reservoirs.
Interesting.
Water has a high heat capacity, so it could absorb heat during the day and release it slowly, keeping these areas warmer.
Which would be huge for habitability.
Absolutely massive.
So everything from volcanoes to weird rocks to actual oceans could be behind these hotspots.
That's the beauty of science. There are so many possibilities.
It's true. But, beyond the fascinating atmospheric details and surface features, we come to what many believe is a crucial ingredient for any chance of life:
Protection from the star itself.
a magnetic field.
You got it.
For years, a major concern about Proxima B's habitability, especially orbiting a red dwarf star known for its powerful flares, was the potential lack of a strong magnetic field.
Right. A big concern.
Yeah, I mean, the worry was that being tidally locked might prevent the kind of planetary dynamo that generates a global magnetic field, leaving the atmosphere vulnerable to being stripped away by stellar radiation.
Yeah, which would be a definite deal breaker for life as we know it.
Total deal breaker.
Right.
But The quantum AI analysis of the planet's electromagnetic signature revealed something truly remarkable.
They did.
Evidence of a substantial planetary magnetic field.
A big one.
So it's got a built-in shield against those nasty stellar flares.
It seems so the AI detected these subtle polarization patterns in the light passing through Proxima B's atmosphere.
Oh, okay.
And these patterns indicate interactions with the magnetosphere.
The region around a planet dominated by its magnetic field.
Exactly.
That's fantastic news. So Proxima B is looking a lot more habitable than we thought.
It really is. Dr. Natalie Battaglia, a scientist who worked on the Kepler mission,
Right.
emphasizes just how essential a robust magnetic field is for planets around M-dwarf stars like Proxima Centauri.
Yeah.
These stars are prone to unleashing powerful flares that can be incredibly damaging to a planet's atmosphere. Finding evidence of this magnetic shielding dramatically improves Proxima B's habitability prospects.
That's huge. I think a lot of people had written off Proxima B because of that flare risk.
I think so.
This changes everything, doesn't it?
It really does. It means Proxima B is far more shielded than we thought,
Right.
which
Right.
drastically increases its potential for atmospheric retention.
Which is crucial for life as we know it.
Absolutely.
But I know science is rarely that straightforward.
You're right about that.
Are there any other perspectives on this?
Well, there are always nuances to consider.
Sure.
Dr. Fantian, an atmospheric scientist, while acknowledging the significance of the magnetic field discovery,
Yeah.
reminds us that Proxima B still receives a staggering 400 times more X-ray radiation than Earth.
400 times.
400 times.
Uh-huh.
So while a magnetic field helps, it would need to be exceptionally strong.
To truly maintain those suitable conditions.
Right, even for simple life over long periods.
So protected, but still in a pretty harsh neighborhood.
That's one way to put it.
So life would really have to, work for it.
It would. But Dr. Lisa Kaltenegger takes a more measured but still optimistic view.
Okay.
She points out that the detection of a magnetic field opens up entirely new possibilities.
How so?
Even if conditions aren't ideal for complex life as we currently understand it,
Right.
we know that life on Earth has adapted to incredibly extreme environments.
Right. Life finds a way.
Exactly.
Yeah.
She suggests we shouldn't underestimate the potential for even simple life to find a way on Proxima B.
I love that. And it's interesting how all these discoveries seem to be interconnected, right? The
Yeah.
magnetic field protecting the atmosphere, which then allows for those seasonal cycles and potentially those thermal oases with liquid water.
Right.
It paints a much more promising picture overall.
It does. The protection from stellar radiation combined with the atmospheric cycling and those intriguing thermal patterns does create a far more hospitable scenario than we previously imagined.
And we can't talk about all this without digging into the how
Yes.
this wasn't just a lucky glance through a telescope.
No.
This was all thanks to some seriously cutting-edge technology.
Quantum AI.
Quantum AI. So for those of us who aren't quantum physicists, can you break down what exactly quantum AI is
Sure.
and why it was so crucial here?
Certainly, quantum AI at its core is a hybrid approach that blends the principles of quantum computing
Okay.
with the power of artificial intelligence algorithms.
Gotcha. So you know how traditional computers use bits, which are either a 0 or a 1?
Right.
Quantum computers use quantum bits or qubits.
Yes.
Which can exist in multiple states simultaneously thanks to a phenomenon called superposition.
Right. It's like a coin spinning in the air before it lands.
Okay.
It's not heads or tails, but a combination of both until we look.
Right.
Qubits can be in multiple states like this,
Yeah.
simultaneously allowing much more complex calculations.
So instead of a simple yes or no, they can be kind of maybe or both at the same time.
Yeah, a good way to think about it.
That's wild.
It's like having 1,000 detectives looking for clues at the same time instead of just one.
So much faster.
Exactly. And when you're dealing with the immense and incredibly complex data sets coming from the James Webb Telescope,
Right.
which is observing Proxima B across multiple wavelengths and over extended periods,
Right.
this ability to test thousands of correlations at once becomes absolutely critical.
So that's why quantum AI is so important here.
It is Dr. John Preskill,
Eh.
a pioneer in quantum computing, put it well.
What did he say?
He said that quantum algorithms excel at identifying hidden correlations in complex data sets.
Makes sense.
Traditional computing might take months, even years,
Wow.
to detect subtle patterns that quantum-enhanced systems can find in days or even hours.
That's incredible. And the Webb telescope is certainly generating those massive data sets.
It's near infrared spectrograph, or NISPEC. It's
Yeah.
essentially like a super sensitive nose sniffing out the different gases present in Proxima B's atmosphere.
By analyzing the specific colors of light they absorb.
Exactly like a cosmic fingerprint reader.
I like that.
And then you have the mid-infrared instrument, or MIR,
Right, the heat camera.
precisely capable of detecting incredibly tiny temperature differences on the planet's surface from vast distances.
And we're talking about,
We're talking about sensitivities down to 1/10 of a degree Celsius.
wow.
But all this incredible data is raw and it's messy.
Right.
You've got interference from all sorts of cosmic sources, from dust to the overwhelming brightness of Proxima Centauri itself.
Yeah, that makes sense.
Filtering all that out is a massive computational challenge.
And that's where the limitations of previous observations came in, right?
Exactly.
Even Hubble couldn't quite give us this kind of detail.
It just didn't have the same capabilities.
So what did this quantum AI system do differently?
Well, it didn't just look at each piece of data in isolation.
Right.
It created a comprehensive, multidimensional model,
Okay.
incorporating all the different wavelengths, the time variations, and the spatial information all at once.
Wow.
This holistic approach allowed it to spot those subtle correlations that traditional methods simply missed.
Can you give us a concrete example of how this made a difference?
Of course.
Especially with those initial methane readings.
Sure, when traditional analysis looks for methane, it typically searches for specific absorption features at certain wavelengths of light.
Yeah.
The quantum AI system took a much broader view.
Gotcha.
It examined how those same absorption features changed over time,
Right.
and how those changes correlated with fluctuations in dozens of other atmospheric components.
Okay.
It was by seeing these interconnected patterns, these subtle dances between different molecules over time,
Yeah.
that the cyclical nature of the methane concentration potentially linked to those seasons was revealed.
So the patterns were likely always there in the web data.
They were.
But without the advanced processing power of quantum
I
AI,
just couldn't see them.
they were undetectable.
Precisely.
That's incredible. So we had the data all along, but we needed a whole new way of looking at it to unlock these secrets. And for someone following the search for life beyond Earth, this quantum AI breakthrough could potentially unlock a treasure trove of information hidden in existing telescope data.
You're absolutely right. It's like having a brand new set of eyes.
So what does the future hold now that we have this quantum key?
Well, the discoveries we've discussed have fundamentally reshaped our understanding of Proxima b,
Yeah.
revealing it as a far more dynamic and potentially hospitable world than we ever imagined.
And I hear NASA's already planning to spend a lot more time looking at Proxima b.
Oh yeah, they've already announced an extended observation campaign dedicating an additional 200 hours of Webb telescope time to Proxima b over the next 6 months.
200 more hours?
200 hours.
That's amazing.
This will give the quantum AI even more detailed data to analyze, potentially revealing even finer details about the planet's surface and atmosphere.
So what kinds of things will scientists be looking for in that new data?
Well, they'll be looking for more clues about the nature of those thermal oases,
Okay.
trying to determine whether they're caused by geological activity, thermal inertia, or maybe even liquid water.
Right.
They'll also be studying the magnetic field in more detail
Oh.
to see how effective it is at shielding the atmosphere from those powerful stellar flares.
That makes sense. And it's not just about more data, right?
Right.
NASA is also actively developing next-generation quantum AI systems specifically tailored for analyzing exoplanet data.
They expect these enhanced systems to be up and running by early next year.
So even more powerful tools to uncover those hidden patterns.
Exactly, which promises even deeper insights, not just for Proxima b, but for thousands of other exoplanets already in Webb's observation queue.
Wow, so this could open the floodgates to a whole new era of exoplanet discovery.
I think it will. Dr. Jessie Christensen at NASA's Exoplanet Science Institute summed up the general feeling of cautious optimism.
What did she say?
She said that while we're not claiming to have found life on Proxima b,
Right.
we've certainly discovered a planet with far more favorable conditions than our previous models predicted.
Right, and this is forcing us to rethink what makes a planet habitable.
It is, especially around those abundant red dwarf stars.
Absolutely, and the implications are much broader than just Proxima b.
Well, much broader.
The success of quantum AI in pulling these hidden patterns out of Webb's data
Yes.
suggests that we should probably go back and re-examine existing data sets from other exoplanets.
I think so too.
Worlds we might have previously dismissed as uninteresting
Right.
could be harboring similar secrets, just waiting for the quantum AI to uncover them.
It's a very exciting time to be studying exoplanets.
It really is. It feels like just the beginning of what quantum computing can reveal about the universe.
The possibilities are endless.
This deep dive into Proxima b, powered by the incredible capabilities of quantum AI, has been nothing short of transformative.
I agree.
We've gone from a basic understanding of our nearest potentially habitable neighbor
Yes.
to a world with fluctuating methane,
Right.
unexpected seasons,
Huh.
mysterious thermal oases,
Yeah.
and a protective magnetic field, a far cry from the barren world many initially envisioned.
It's amazing what a difference a little quantum AI can make.
It really is, and it leaves us with a profound question to ponder. Considering these surprising findings, the dynamic atmosphere, the potential for liquid water in those warm zones, and the shield against stellar fury,
Yeah?
what possibilities for life, perhaps in forms we can scarcely imagine,
Right.
might exist on worlds we once considered desolate?
What a great question.
What further questions does this raise for your understanding of the universe and our place within it?
The exploration has just begun.